In this video, I'm going to be covering question 6, part C from the 2019 AP Calculus AB free response, no calculator allowed portion of the test. I cover parts A and B in their own video and part D in its own video, so if you want to see those solutions, please check out my other videos. All right, so let's take a look at C. There's a lot happening on C. It's really not that rough of a problem, but there's just a lot of moving pieces to keep track of. So first off, they're giving us that this function here, h of x is equal to x squared minus 4 over 1 minus f of x to the third whenever x does not equal 2. And then it's telling us that the limit of that function can be evaluated by using L'Hopital's rule. Then using the limit, which means using L'Hopital's rule probably, they want us to find specifically the value of f of 2 and f prime of 2. So f of 2 is that function inside this equation right here. F is not described anywhere else except in that little piece right there. So let's start off by going after f of 2. So to find f of 2, we're going to be using this idea about L'Hopital's rule. It has to be important, right, or else they wouldn't have made a big deal about it. So what does L'Hopital's rule say? I'm just going to abbreviate it so we don't have to see me write it out a whole bunch. I'm going to call it LHS rule. So L'Hopital's rule says the limit as x approaches some number of two equations being divided. These f's and g's are just from a definition. They have nothing to do with the specific f and g's in this problem. That if you get out what's known as an indeterminate form, which is 0 over 0 or infinity over infinity, only when this situation happens can you apply L'Hopital's rule. And so what we know is they've told us that this thing can be evaluated using L'Hopital's rule, which means that the original limit of this function here has to fit one of these indeterminate forms. So let's go kind of take a look at what this limit is and see what's happening. So we would say I have the limit, so we're working with the limit they told us we could use for L'Hopital's rule. So the limit as x approaches 2 of h of x. Well, h of x is this equation here. So instead of putting in h of x, we're going to put in x squared minus 4 over 1 minus f of x to the third, and that all is going to equal. So we look at this, and what you'd want to say is like, how do I know which of these two situations I would be in? Well, the top equation we can plug in and get a value out and see what's happening there. So I would take 2 and I would plug it into the top, and I would see that I have 2 squared minus 4, and then that is all going to have to equal 0 on top when I come through there, right? So what I know is the format of this problem to get me the way that I can apply L'Hopital's rule to satisfy what has to happen to apply L'Hopital's rule is I need to be in a 0 over 0 setup. And so what that tells me then is when I plug 2 into the bottom here for x, 1 minus f of 2 to the third, that all of that also needs to equal 0. So we kind of pull that information out and set up this little math problem where I set these two chunks equal to each other. So I know that if L'Hopital's rule is going to be allowed to be applied, that this equation here has to also equal 0. So I end up in one of these indeterminate forms. You know, it's pretty straightforward to kind of look at this and see that f of 2 would have to equal 1 because you need a 1 minus 1 to get you 0. But if you needed to kind of work the algebra, if that didn't appear to you obvious, go ahead and just solve for f of 2 like it's any other variable. Subtract that 1 over to the other side. Let's get f of 2 by itself equals negative 1, and then we would go ahead and divide by negative 1, divide by negative 1. We get f of 2 to the third is going to equal negative 1 divided by 1 gets us positive 1. And then you would go ahead and cube root that. Cube root both sides to cancel out the cube. And you'd end up with f of 2 equals 1. So we have one of the bits of information here under control. So we know what f of 2 is. And now we need to go find out f prime of 2. Well, how do we do that on this problem? That is going to come from the fact that we can apply L'Hopital's rule. And so what L'Hopital's rule says is the limit of this original function is equal to the limit of its derivatives. So that limit is going to be equal to the limit as x approaches a of the derivative of the top equation over the derivative of the bottom equation. So from doing that, we are going to be able to get an f prime to show up on us here. So we're looking at this equation here, and we want to apply L'Hopital's rule. So we would say limit as x approaches 2. So we're going to start now by taking the derivative of the top equation, the derivative of x squared following the power rule, bring the power down, that would be 2x, and then the derivative of negative 4 is a constant, so it goes away. Then when we come to the bottom here, we're looking at this problem 1 minus f of x to the third. So we're trying to take the derivative of that piece. The derivative of 1 is a constant, so that would go away. Then looking at this piece here, this would be a chain rule because we have a function inside another function. And so my chain rule recipe that I use goes d in times d out. The derivative of whatever is inside, which in this situation would be f of x, times the derivative of the out. So taking that derivative, the derivative of the in would just be a notation game. The derivative of f of x would be f prime of x. Then we'd multiply that by the derivative of the outside, which is just going to be a giant power rule. I would bring the 3 down in front. I still have that negative there, so this would be negative 3. You leave alone all the junk you already took the derivative of, and then you would subtract 1 from that power, which would give us a 2 here. So L'Hopital's rule says that this limit is going to equal the limit that we started with. And so from there, we come through and we can now start trying to plug in some values. So again, we would take and we would plug 2 in everywhere we see an x in this equation. So I'm going to plug in 2 here, plug in 2 there, and plug in 2 there. So out of here, we would get 2 times 2 over f prime of 2 times negative 3 times f of 2, and all of that is squared. So if we keep working through this right now, we'd see that, okay, that's going to be equal to, on top, 2 times 2 is 4. On bottom, f prime of 2, that's the piece I'm trying to find right now. I don't know what that is. Then I've got negative 3. Then f of 2, we found out in the first part of this that f of 2 is 1, so that's going to be 1 squared. And then cleaning this up a little bit more, we would get 4. Negative 3 times 1 is going to get us negative 3 times f prime of 2. So here, what we're looking for, what this problem's begging for, is we need to be able to set this equal to something. And so what you would say to yourself is, how do I know what the answer to this limit problem is? So look at what this limit really was. Remember that this was the limit as x approaches 2 of h of x. What do we know about this? This would be equal to h of 2. And so, again, just kind of taking that 2 and plugging it in everywhere you see an x, these two things would be equal as long as we know that what we're looking at here would be continuous. Well, if you look back at the original language of the problem tells us that these are twice differentiable functions, right? And so that if it's differentiable, it has to be continuous. And since it's continuous, I know that the limit and the function value, the dot on the graph, have to equal the same thing. So I know h of 2 equals 4. So I know that the limit as x approaches 2 of h of x, the final answer to that has to equal 4. And that was where we started. Remember, they were using this funky equation for h of x here because we're trying to find these f of x values and these f prime of x values. But in the end, it's still the same h that they're talking about through the whole equation. So we know the answer to this limit problem has to be 4. So then we can set this equal to 4 over here. And now we have an algebra problem that we can finish solving to get that f prime of 2 by itself. So the next thing that I would do here, sort of kind of envision, let's maybe drop this down. So what we're really looking at now is solving this little math problem here. So we want 4 over negative 3 times f prime of 2. That has to equal 4. Well, we're not solving for f prime in the bottom of a fraction, so the first thing I would do to solve for that is multiply both sides by f prime of 2 to get it out of the bottom. So then I get 4 over negative 3 is going to equal 4 times f prime of 2. And now I need to cancel out that 4. So I'm going to multiply both sides by 1/4. And what I can see is this 4 on bottom is going to cancel with that 4 on top. That's going to leave me 1 over negative 3, or negative 1/3 has to equal f prime of 2. And that's the last piece of the puzzle here. So there was a lot of moving pieces here, but not all of it was that rough, right? Let's recap. We used the indeterminate form portion of L'Hopital's rule to find out what was going to make that bottom equal 0. Then we applied L'Hopital's rule. We took the derivative of the top and the bottom to get ourselves a little f prime of x because we needed to be able to solve for that, and we didn't have an equation that used it. And then we solved that limit problem, and we reminded ourselves that because this was a twice differentiable function, we actually knew what the answer to the limit had to be because it had to also equal where the dot on the graph was. And we popped that piece in and solved the rest of that equation to get the second part of our problem. So this was a big one. The points here kind of came first and foremost. I guess they kind of, this piece here, making that leap of understanding there, knowing that that limit had to equal 4 and using that over here was for a point. Finding out f of 2 was 1 point. Finding and applying L'Hopital's rules, so going from that position to this position was another point. And then getting out our final answer for that derivative was our fourth and final point. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.